Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to partial differentiation of differential calculus. Prove that if f, which is function of xy, equal to 1 upon square root y e to the power minus x minus alpha whole of square upon 4y, fxy equal to fyx, both are function of x and y. So we are given that f is function of xy, which is equal to 1 upon square root y e to the power minus x minus alpha whole of square upon 4y. I write it as equation number 1 and differentiate it partially with respect to x. Differentiating f xy partially with respect to x, we get fx, which is function of xy. For x, 1 upon square root y is constant, so I take out it as a constant, 1 upon square root y constant, and differentiate it considering this value is x, e to the power x. Differentiation of e to the power x is e to the power x. X means here minus x minus alpha whole of square upon 4y, but it is not x. So by chain rule we must differentiate it with respect to x partially. So I differentiate minus x minus alpha whole of square upon 4y partially with respect to x. 1 upon square root y, write it as without any change. I write it first here minus 1 upon 4y is a constant, and differentiate partially with only with respect to x minus alpha whole of square. Right now this e to the power minus x minus alpha whole of square upon 4y is equal to, we can take out minus to here 1 upon 4 times y square root y, and differentiate on differentiation considering x minus alpha is x. So differentiation of this to x, what it is not x, which is equal to x minus alpha. So differentiated with respect to x, we get differentiation of x with respect to x1, and differentiation of alpha is 0, multiplied by this value e to the power minus x minus alpha whole of square upon 4y. We cancel out 4 from by 2, we get minus 1 upon x minus alpha multiplied to 1 is equal to x minus alpha upon 2. Degree of y here 1, and when we take off this bracket, we get y to the power 1 by 2, and multiply to 1 power equal to y to the power 1 and 1.5, which is equal to 3 by 2. So y degree of y is here y to the power 3 by 2. Now we have to write this value only, e to the power minus x minus alpha whole of square upon 4y. Now I get only this value means fx xy is equal to, and we should take it in numerator, so I can write it as x minus alpha upon 2 into y to the power minus 3 upon 2 by indices law, because this value go to from denominator to numerator multiplied by e to the power minus x minus alpha whole square upon 4y. Now differentiating again partially with respect to y, we get f yx x comma y. It comes this on differentiating this value with respect to y, which is equal to del over del y fx xy. Now I put the value of fxy, which is this value x minus alpha upon 2 into y to the power minus 3 by 2 into e to the power minus x minus alpha whole square upon 4y. Now we have to differentiate this value, but we are seeing that this is constant for y, because for y x is constant, and because this is partial differentiation, so I can take out this value x minus alpha upon 2. Only we have to differentiate this value y to the power minus 3 by 2 into e to the power minus x minus alpha whole square upon 4y. So by applying product law, we can write it as, this is value of f yx xy equal to minus x minus alpha upon 2, and now apply formula. We consider it as a first function, and this is a second function, and differentiate according to formula. First function as it y to the power minus 3 by 2, differentiation of second function, which is e to the power x to e to the power x, therefore e to the power minus x minus alpha whole square upon y. But it is not y, because we consider it y, because we differentiate it with respect to y. So by chain rule we should differentiate it with respect to y partially, x minus alpha whole square upon 4y. First function as it differentiation of second function plus second function as it e to the power minus x minus alpha whole square upon 4y, and differentiation of first. Differentiation of y to the power minus 3 by 2 is minus 3 by 2 power is come to here, and y to the power minus 3 by 2 minus 1 according to formula. We close this bracket and go to the next step. We should go to the next step and write this value without any change. So I write minus x minus alpha upon 2, and for simplification we must take out e to the power minus x minus alpha whole square upon 4y as common out from this bracket. Then we get y to the power minus 3 by 2, and this bracket because for yx is constant, so I take out minus x minus alpha whole square upon 4 as common, and only differentiate 1 upon y. We can take it to numerator, so y to the power 1 here, so on taking it to numerator it becomes minus 1. Now we should write second term, but this sign is change from by this minus, so it become minus and this value is taken out from bracket, so we have to write minus 3 by 2 y to the power minus 5 by 2 on adding these two values is equal to, if we take out minus common out from this bracket, then this sign becomes positive, so I write x minus alpha upon 2 into e to the power minus x minus alpha whole of square upon 4y multiplied by this minus is taken out from bracket, only this value I write here y to the power minus 3 by 2 into x minus alpha whole of square upon 4 multiplied by on differentiating this value, so this power is right here, and after writing this we should subtract minus 1 from this power. According to formula, I get this value minus 3 by 2 y to the power minus 5 by 2 is equal to x minus alpha upon 2 e to the power minus x minus alpha whole of square upon 4y, and this sign convert this sign into negative, so I write it here minus and write this value x minus alpha whole of square upon 4 and power of y is equal to minus 2 and minus 3 by 2, and write it when we take out minus from this bracket and after converting this minus sign to plus, then both the sign will be positive. This sign is positive and also this sign is positive. I have committed a mistake, so I correct it here because I take out this 2 minus 2 here, so this become positive and it also become positive, and this sign minus convert it to minus, and what this sign is positive plus ka 3 by 2 y to the power minus 5 by minus 5 by 2. We can write it as x minus alpha upon 2 e to the power minus x minus alpha whole of square upon 4y. There is no change. We can write now positive value first. I write first divided first 3 upon 2, and if we can change degree of y, positive y, taking into denominator, so I write it in denominator, then the sign becomes positive from negative 5 by 2, and right now this negative value minus x minus alpha whole of square upon 4, and also add this value 2, and when we take it to denominator, it become plus 2 and 3 by 2. On adding this value, we can take LCM. 2 4 plus 3 which is 7 by 2, so we can write in denominator 7 by 2 here as is equal to x minus alpha upon 2 e to the power minus x minus alpha whole of square upon 4y, and now I take LCM. 2 and 4 LCM is 4, and we should write greater power in LCM. 7 by 2 is greater than 5 by 4, and dividing this to this we get 4 divided by 2, yeah, 2 multiplied to here become 6 minus 6 minus and difference in power is 1, so I write here y. On dividing this value to this, we get I write here, I show here y 7 by 2 divided by this value 2y to the power 5 by 2 and 4 cancel out by 2, and because base is equal y, so I subtract 7 by 2 minus 5 by 2, and difference is 2 upon 2 is equal to 1, so I write 1 here, but 1 is not necessary to write here, so I go to next term. This is completely cancel out, so I write only this value, denominator x minus alpha whole up square, and it is simplified value. This is value of f yx xy is equal to, we can write it as x minus alpha upon when we multiply numerator to numerator, it becomes 4 to the 8 y to the power 7 by 2, and multiply by e to the power x minus alpha whole up square upon 4y, and this bracket 6y minus x minus alpha whole up square. I write it as equation number A. And now differentiate, we should find the value of left hand side, so we differentiate equation 1 first with respect to y. So I write here differentiating f xy with respect to y, we get fy xy is equal to del over del y fxy. From equation 1 we write the value of fxy, which is equal to 1 upon square root y into e to the power minus x minus alpha whole up square upon 4y. I can write it as, because square root y equal to y to the power 1 by 2, and when this value is go to numerator, then it become y to the power minus 1 by 2. So here is two functions which have to differentiate with respect to y. I consider it as first function, in it as a second function, and apply product law. Then we can write we find the value of we have fy xy is equal to first function as it differentiation of second function with respect to y e to the power minus x minus alpha whole up square upon 4y plus second function as it x minus alpha whole up square upon 4y differentiate with respect to y, which is a second function, differentiate second function with respect to y. Y to the power minus 1 by 2. Now differentiate it considering it is y, so e to the power y differences e to the power y. What you are seeing here, it is not y, so differentiate according to chain rule, minus x minus alpha whole up square upon 4y plus write it now, and then differentiate this value e to the power minus x minus alpha whole up square upon 4y. On differentiating this value, this power become here and come to here, and this power becomes minus 1 by 2 to minus 1 according to formula, is equal to y to the power minus 1 by 2. And we can also take out some power common, so that our calculation is becomes easier. So first of all I take out e to the power minus x minus alpha whole up square upon 4y is common out from this bracket. From this and this we get this value y to the power minus 1 by 2 and del over del y. This value x minus alpha whole up square upon 4y and plus write this value this out from this bracket, and we get 1 minus 1 by 2 y to the power. We can add this value which becomes minus 3 by 2 e to the power minus x minus alpha whole up square upon 4y, and we go to next vector minus 1 by 2, and because here it is partial differentiation for y x is constant, so we take out this value minus x minus alpha whole up square upon 4 from this bracket. Only differentiate 1 upon y, so we take y to numerator, it become y to the power here plus 1, so numerator it becomes minus 1. Plus minus becomes minus 2 on multiplication, and y to the power minus 3 by 2. It is completely solved. We go to next term. Here e to the power minus x minus alpha whole up square upon 4y, and this value we can write in here in first y to the power minus 1 by 2, write x minus alpha whole up square upon 4 and differentiate it according to formula. Minus, take minus 1 is here, and y to the power minus 1 and minus 1. Differentiation is done here. Minus 1 upon 2, and if we want to change it positive, we should take it to denominator, so y to the power plus 3 by 2 becomes 3 plus 3 by 2. So e to the power minus x minus alpha whole up square upon 4y, and on multiplication minus minus becomes plus, and we should collect power of y, and we write x minus alpha whole up square, and this becomes plus and upon 4, and we should collect the power of y. Here it is minus 1 by 2, and this value is minus 1 minus 1 minus 2, minus 1 by 2 and minus 2, it becomes minus 5 by 2, minus 1 upon 2 y 3 by 2, and we can also write its denominator, and this value f y x y become e to the power minus x minus alpha whole up square upon 4y, and x minus alpha whole up square upon 4 y to the power 5 by 2 minus 1 upon 2 y to the power 3 by 2. Now differentiating again partially with respect to x, this value become f x y, which is on differentiation, which is we obtain differentiation of y x y with respect to x, and this value is we obtain in last steps. So I write this value from here, e to the power minus x minus alpha whole up square upon 4y multiplied by x minus alpha whole up square upon 4y to the power 5 by 2, and minus 1 upon 2 y to the power 3 by 2. Close this bracket, and now we should apply the product to the first function and consider this bracket as a second function, and apply formula. First function as it e to the power minus x minus alpha whole square upon 4y, and differentiation of this value, differentiation of this value. So on differentiating with this value with respect to x, we are seeing here x is variable and y is constant. So when we differentiate this value, 1 upon 4 y to the power 5 by 2 is constant, we take out it here and differentiate this value with respect to x. So consider it x square differentiation is 2x, which becomes 2x minus alpha. But we are seeing that it is not x, so differentiate this value with respect to x, which become 1 minus 0. You can write only this value directly. Then after it we are now differentiate whole value. Differentiation is of this value is done here. What we have to differentiate this value. What for x, this value is constant, wholly constant, so differentiation is constant 0. So I write this value. First function as it, differentiation of second plus second function as it. So I write this value at is x minus alpha whole square 4y to the power 5 by 2 minus 1 upon 2y to the power 3 by 2, and differentiate this value. Differentiate this value with respect to x. So I write here multiply y differentiation of e to the power minus x minus alpha whole square upon 4y. We go to next term. We get now we can cancel for y2, we get 2 here, and in next term we get fxy, xy is equal to function of xy is equal to e to the power minus x minus alpha whole square upon 4y. You can write in previous page bracket. After solving we get x minus alpha multiplied to 1 become x minus alpha, and upon only we have 2 y to the power 5 by 2, 2y to the power 5 by 2. This is and next term this we get in next term we are saying that we should write this value as it without any change, and only we have to differentiate this value with respect to x. So I write this bracket as whole after plus x minus alpha whole square upon 4y to the power 5 by 2. I write whole bracket as it without any change, 2y to the power 3 by 2. And now we have to done something. So differentiate son of e to the power x is e to the power x. We consider it power of e is x, so differentiation of e to the power x is e to the power x. So I write it e to the power minus x minus alpha whole square upon 4y. What it is not x, so I differentiate it with respect to x partially. Differentiate x minus alpha whole square upon 4y, close bracket. I have not space, so you can consider, imagine this is bracket, curly bracket. This first term and this is second term. Now we write we can take out common from these two terms, e to the power minus x minus alpha whole square upon 4y, so that it will becomes easier for us. So write this value x minus alpha upon 2y to the power 5 by 2, and write this value and this value plus x minus alpha whole of square upon 4y to the power 5 by 2 plus minus 1 upon 2y to the power 3 by 2. Now this value is taken out from bracket, so only differentiate this value. For x minus 1 upon 4y is constant, so I take it out, and only we have to differentiate this bracket x minus alpha whole of square. Consider it as x, so x square, it become x square. Differentiation of x square is 2x, what it is not x, it is x minus alpha. So we have to differentiate this value. What we know that differentiation of x is 1 and alpha is 0, it is completed. And now we should close bracket because this bracket start from here, because we have take out common out this value, and we get now e to the power x minus alpha whole of square upon 4y and x minus alpha upon 2y to the power 5 by 2. It is we can write, we are seeing that this minus convert this sign from plus to minus, so it becomes minus, and also 4 is cut off y 2, so it becomes 2y. So I write here upon in denominator 2y. What x minus alpha multiply to 1, it become x minus alpha, so I write here x minus alpha, because these value are in sign with the multiplication. So I write this value now, x minus alpha whole of square upon 4y to the power 5 by 2 minus 1 upon 2y to the power 3 by 2, close bracket, and square bracket also close here. And we are saying that in these two terms x minus alpha is common, so I take out x minus alpha from this bracket. We get x minus alpha after taking out from bracket, so common out from bracket, we get 1 upon 2y to the power 5 by 2 minus 1 upon 2y. It becomes 1 upon 2y, because this is take out from bracket. And now in this bracket we can take LCM for y to the power 5 by 2. Y is here present in both the term, only common LCM is which is greater power, which is 5 by 2, and 2 and 4 LCM is 4. On dividing this value, we get here x minus alpha whole of square minus, on dividing this value, we get 2y. We can show it here as when LCM 4y to the power 5 by 2 divided by 2y to the power 3 by 2, 4 cancel out by 2 by 2, and 2y write y only one times because base are equal, and power must be subtract from numerator power to denominator power, and we get 2y to the power 2y2, and become 1, 2y to the power 1, and because becomes 2y. So I write it here 2y. Now we should multiply denominator to denominator and numerator to numerator. 1 multiplied to this value become this value, and this value multiplied to this we write in next step. So I write it is as x minus alpha into e to the power minus x minus alpha whole square upon 4y and 1 upon 2y to the power 5 by 2 minus 1 multiplied this value becomes x minus alpha whole square minus 2y, and this multiplied to this to becomes 8y to the power 1 power and 5 by 2 power. On multiplication y की power 1 into y की power 5 by 2, it become y to the power 1 plus का 5 by 2 equal to y की power 7 by 2. So I write here directly 7 by 2 here. Yes. On taking LCM in these two terms, we get x minus alpha e to the power minus x minus alpha whole square upon 4y without any change here, and take in these two terms 8y to the power 7 by 2 as LCM. On dividing this value we get 4y and minus this value is same, so I write this bracket as without any change. I write this bracket and open this curly bracket. We get x minus alpha multiplied by e to the power minus x minus alpha whole square upon 4y, and 4y minus x minus alpha whole square minus become plus 2y upon 8 y to the power 7 by 2. 4y and 2y becomes 6y, so I write in next step x minus alpha e to the power minus x minus alpha whole square upon 4y and 6y minus x minus alpha whole square upon 8y to the power 7 by 2. 7 by 2 we can write it in here, and it becomes like equation number A. So I write it as y xy is equal to yxy function of xy equal to x minus alpha upon 8y to the power 7 by 2 e to the power minus x minus alpha whole square upon 4y and 6y minus x minus alpha whole square, which is equation, I write it as equation number B. From equation A and B, we can write as f xy differentiation of f with respect to x and y, which is function of xy, equal to differentiation of second derivative of f with respect to yx, which is function of xy, are equal. We have to be proved. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.